Hey everybody. Today we're talking about the uniform distribution, which describes a continuous random variable with a constant probability density function. Basically, for a random variable like this, probabilities are the same wherever the random variable is defined. For instance, here's a graph of the uniform distribution on the interval 1, 7, and it's abbreviated U parenthesis 1, 7. The probability that x falls into a particular subinterval, a particular range, is just the fraction of the interval that's covered by that range. For instance, in the uniform distribution with starting at 1 and ending at 7, the probability that x is less than 5 is going just to be the width of the interval from 1 to 5 divided by the total width of the interval 1 to 7. We do a little arithmetic and simplifying, we get 2/3. Visually, this means that 2/3 of the area under this graph between 1 and 7 is shaded when we just look between 1 and 5. A couple more examples. Let's compute the probability that x is greater than 6.12. So the width of the interval there is 7 minus 6.12. We divide it by the total width of the interval where this random variable is defined. We get 0.1467. One more example. The probability that x is between 1.4 and 3.8 is going to be 3.8 minus 1.4 divided by 6. Again, the width of the subinterval divided by the total width of the interval where the random variable is defined. In this case, we get 0.4. 40% of the area under this graph is shaded right now. As with any continuous random variable, the total area enclosed under the PDF of a uniformly distributed random variable has to be 1. And since the PDF is constant, we can figure out its equation just by using the fact that we have a rectangle of known width and total area 1. A bit more explicitly, the equation of the density curve is always 1 over b minus a. So 1 over the width of the interval where the variable is defined. So if I have an interval of width 7, in this example that we've been looking at so far in this vid, the equation of the probability density function is f of x equals 1/6. Here's an example for you to try. You should pause the video before seeing my answer. Graph the density curve for the uniform distribution on the interval -5 to 5, find its equation, and then compute the probability that x is greater than 3.5. So the width of the interval here is 10. When you go from -5 to 5, you have a width of 10. So the equation of the density curve has to be y equals 1/10. So I'm plotting the function y equals 1/10 on the interval from -5 to 5 to get this graph. When I evaluate the probability that x is greater than 3.5, I'm shading in the region under this graph corresponding to x greater than 3.5. So that's an interval of width 1.5, 5 minus 3.5. The total width of this interval is 10, so I'm doing 1.5 divided by 10 to get 0.15. That's the probability that x is greater than 3.5.